Welcome. You're listening to Angelneers, the podcast. Angelneers is a Silicon Valley community for startup builders where founders, creators, and operators share their firsthand knowledge on how to successfully build and scale startups. I'm your host, Oleg Kujakov, and our guest today is Mo Tahmasebi. Mo is the founder and CEO of Stonefly, one of the innovators in cost-effective, full-feature storage appliances. I'm excited to bring Mo on to talk about how to navigate the world of hyperconverged infrastructure and learn a little bit more about what that is. Now, Mo, welcome to the show.
Yes, thank you, Oleg. It's nice to be here and talking to you about technology and what journey we have gone through to get here.
Yeah, well, thanks for taking the time to do that. I always like to start these interviews with a little intro of the guest. So, yeah, just tell me, super basic, how'd you even get into engineering in the first place? What was your first foray?
Well, I got to engineering by going to school, So basically, so electrical engineering. And then as part of electrical engineering, we took classes. One of the classes was power. And fortunately or unfortunately, I touched one of the lines which had high power. And it was like a few hundred amps. And I guess whatever it was, it almost killed me. So I changed to computers, So I said, I don't want to touch this big power lines and stuff like that. So, but I want to do electrical engineering. So I said 5 volts is good enough for me. I'm going to switch to 5 volts. That's all I can take. So that's how the computer thing started. And after graduated, I started looking for a job. And the first job I ended up in Atari, which is a fantastic place to be in because it was a combination of, how to get the games into the personal computers.
Awesome. So, tell me a little bit more about that. What were you working on while you were at Atari, and any more about what it was like would be interesting.
So my project basically started from early on, there's big mini computers and things like that, too expensive for people want to just create personal computers. So we set up to do personal computers. And at that point, we had a platform, which was a game system. And so we had a video chip already designed for it, a sound chip for it. So we took these two chips, and then we built, the first personal computer. That processor was 6502, Rockwell International. So it was a very good processor. And then I guess, we introduced models like 400 and 800 of Atari, and personal computer kind of was born at that point because, it was a Commodore, before that a little bit. And after that, I guess, you see Apple, you do the same thing. Apple came to in the parallel kind of thing, doing the same thing that Atari did. So,
well, I don't remember it quite like you do, but yeah, I've heard about it.
Yeah. So, that's how it started. So, I mean, it's good, Then I, after that, I started with another company, which was a startup at that point. It's, when I joined it, almost. The name was, Stanford University Network, and it turned out to be SUN, which is Sun Microsystem. So that's how the Sun was. And so it was early on. And then we started saying, okay, now we got to build big computers, bigger than the personal. But it has to be somehow it can do engineering work. So we focused on, CAD system, which was basically computer-aided design. And so that was the first application or use case for this type of computers, which had more power and was a Unix-based system, which gave them people more flexibility as far as operating system. And then, so it got more advanced and people use it for, programming a lot. So programmers became very interested to use that because it was a Linux-based system, Unix-based system. And then, we got into other use cases, which basically internet, right? So internet between universities and everything I think at that time was financed by DARPA. So we worked on it. So that's how internet, I guess, kind of got started between universities and, and then expanded from there. And so I was at Sun. And then after that, I started a number of companies after that, which is basically we're mostly in the system areas and software development and system areas until we started on storage.
Yeah, and that was Stonefly.
Stonefly, mostly there was a dynamic network factory which basically merged and became finally Stonefly. So because we had multiple companies and we merged them together, now it came out to be Stonefly, which is very focused on the storage. So it first pioneered kind of working on a protocol because everything at that point was direct attached storage. So it means you had a bunch of disks, and then before that I worked on many products at Sun, storage products. So that's what I was very familiar with those, and so when I went to this ventures with creating products as far as the storage, then I brought that knowledge, and then as I said was mostly direct attached products. Which we used iSCSI as a protocol. Then we kind of added I in front of it, basically, and became iSCSI. And iSCSI means what's like, it's has a internet aspect, means it's a network connected storage. So I basically make it a network connected SCSI product, and became iSCSI at that point. And we started, a domain name registered called iSCSI.com, and protocol at that time, number of companies worked on it, and we worked on it. And it was released, I think, in 2002 as a standard protocol for network attached storage products, as a block mode storage. And then it went against Fiber Channel product, which, many years we started evangelizing iSCSI as a protocol. So now it's probably, I call it number one protocol for the storage industry, and I think Fiber Channel is kind of diminished, and iSCSI took off, and then now it is millions and millions of people are using iSCSI product or iSCSI protocols.
So how does that tie to Stonefly? Can you tell me what the original idea was for Stonefly, and then kind of the company was founded in 2000, I believe. What's happened since then?
Yeah, so it's still the same idea. It's working on the storage and use cases of the storage. So it's kind of, the secret sauce is behind all our products. It's we are storage-centric companies. And so when you're a storage-centric means you deal with data. And data, changes over a period of time, how you acquire data, how you get the data, and how do you store it. How do you protect it? Things like that. How to manage it. So all these stuffs get on the top of it, and it changes right through the time. All this stuff. So protocols that starts coming in. So we worked on iSCSI to make direct attached storage to a network attached storage. Right. So iSCSI, that's what it did. And other protocols were also, which is a file-based protocol. It's called NFS or CIF, which is basically it's used for shared repositories, and that's also another protocol that it's people use for getting the data into the storage or storing the data. And then now recently, of course, S3 object storage has another thing that it gets you there, which is the REST protocol. So basically these three are over a period of time we develop product based on these protocols to acquire the data. Then of course the internal system changes, and one of the most important one, the tier of storage, which went from a SATA to a SAS to SSDs and then NVMEs. So basically the interface changed, so it has become faster and faster and better. So that's another changes that you see in the industry. And then high availability is another one, scalability, which is getting added to the mix, so creates more scalability and high availability for a storage product. So, and then alongside of that, the storage gets integrated as part of its life to combines the storage and servers and network, so all get virtualized, because not only the technology of several technology changes became like virtualization with VMware and Hyper-V as a hypervisor or Zen or KVM. Also, the storage becomes virtualized. So that's what we start virtualizing. Another big change that we provided in starting 2010 in that range and in that time frame, which was storage virtualization, and then combining the network and the storage virtualization and servers all together, and that's what's called Hyperconverged appliance, HCI. That's what you're doing.
Can you explain HCI? But I guess we got that, and we got the main components.
Yeah, so that's how it happens. It basically, again, when you needed to kind of utilize your hardware more efficiently, so as part of efficiency of usage of the hardware is you virtualize. So that was a server virtualization. Then we thought, okay, so why not storage? Then the storage stack was virtualized. Then, we also said, how about network? So network got virtualized, which was as part of the servers. Virtualization came with that. So combining all these three together became hyper-converged appliance. Means we converged all these different resources.
Yeah. And what are the benefits of storing data and backing it up this way?
Well, the biggest thing for hyper-converged appliance, of course, is hardware utilization. Your hardware, it gets partitioned, between different servers. So you can actually have different servers running on the same hardware platform, which used to be what we call physical and not virtual. So if it's a physical appliance, means that it's bare metal. It's only that particular operating system runs on that one server, and versus the virtualized servers, of course, you got multiple virtual machine, which are the same servers that was physical. Now you can actually put on the same server, and that's the virtualization. So means that now you can host different or multiple virtual machine or servers on the same hardware. And so your hardware utilization goes much, much higher because of the cost of one server with virtualization is going to be cost effective rather than buying 5 systems or 10 systems doing the same thing. When you virtualize, you really efficiently use your CPU, memory, and other storage and everything else, right? So that's what the whole idea is. And Hyperconverged, of course, added your external storage and virtualized it and became part of the equipment, and then everything all together in one place. Basically, maybe a small data center in the box. Everything is in one box. And also, we recently, last few years, we decided, HCI is great technology. Of course, if you look at HCI, became more or less that's what you see in the cloud. Cloud is a sort of HCI, which its own hypervisor, basically, right? And some of these hypervisors are based on like KVM, like Amazon, right? So it's the same HCI, but a big HCI. That's all it is. And, you also have like Azure, which is Hyper-V version of the hypervisor running. And the difference between cloud and your local HCI, basically call it, is that you have more control over your local HCI versus cloud HCI, because they won't give you access as much in the hypervisor, managing the hypervisor. So there's limitation there. But in your HCI local, is you have more control. You have full control over your hypervisor. So that's pretty much the journey of the hypervisor. The HCI going to become eventually, same idea, that you see, that's called cloud.
Well, that's really interesting. And I think I get the difference between traditional data storage solutions and this HCI solution as being everything's virtualized and partitioned in a way that you can treat it like a black box, maybe. Why would you want to do that? Tell me about everyone is trying to put their information and data in the cloud. Everyone's trying to make use of the cloud. Everyone probably wants to make use of big data centers. I'm sure talk about how they can put hyperconverged infrastructure to use. So why would you want to do that? What are the benefits compared to like traditional data storage and backup?
Well, which one? The cloud is what is the advantage of the cloud versus HCI or versus the or traditional bare metal systems?
Yeah, HCI versus traditional systems is what I was asking.
Well, it's just a server utilization, so hardware utilization. So you have much better hardware utilization. You can use, let's say you want to build 5 servers, like, you want email servers, you want application servers, you have accounting servers, you have, let's say you have 5 different use cases for building applications. So you might go buy 5 servers, right? And that's okay. This is my email server. This is my accounting server. This is my, application, whatever else application server I have here, and so on and so forth. So that costs you 5 servers. That's called physical. Now you can take and go and buy 1 server and then basically put all these 5 applications or 5 things that you have in that 1 server. So now you spend it 1 versus 5, right? And protect 1. And then, there's some other things is, for example, when you back up, we call this host. So when you go to virtualization, you call it host. So when you back up the host, which has all this virtual machine on it, you can use agentless backup. Means that you don't really have to put agent in every virtual machine that you have, because the hypervisor provides a way of taking snapshots of those machines, and you can do backups of the whole thing from the hypervisor. You don't have to go into each virtual machine. So this way is actually processing much faster, much more reliable, and so on and so forth. So, and you can create different things, so as a backup, snapshots, replications, and things like that. That you can actually have more data protection capability and also management capability. And, you can consolidate everything to, much better management, interfaces.
HCI is best suited for workloads that are making use of horizontal scaling rather than vertical scaling. How does HCI handle scalability and performance for organizations in terms of storage and recovery? With that in mind, can you talk about that?
Yeah, I mean, it's basically the scalability is great because you can scale from 1 node and a few virtual machines to hundreds and thousands virtual machines with adding more nodes. And, so it supports pretty good scalability. Also, when you add, you can manage performance by allocating resources like CPU and memory to the machines that they require higher performance load and performance. And so you can manage performance by allocation of the resources you have much better than, with the single, physical appliances that you might have. So performance and scalability is more or less definable by you, from resources you have. And that gives you good management. Also, as far as backup and disaster recovery, it's much easier, because now you can have integration, which we have in the sense in our DR365 product, especially the DR365V product, is that we have integrated our immutable and air gap system, which is right now in these days is critical to have because of the ransomware, malwares, viruses, hackers, all people who are trying to get to your data and put you out of business, basically. So what we do, we create immutability. Immutability means that we can store the data and assign metadata to it, and when we write it, so it's not deletable for X amount of days, months, years. Whatever policy you assign for that particular data, so that data is immutable, not deletable. So when it's not deletable or modifiable, means that Ransomwares cannot do anything to it. Malwares, viruses, hackers, it's just not there. And air gap also means that when you're using it, the repository or the controller or the node is attached, means it's active, it's there, it's available to you. But when it's not used, it disconnects it. It puts it in a vault and locks it down. So it means, it's not available for ransomware to attack it, or malwares or viruses or even hackers. They don't see it. It's not there. It's disconnected pretty much. So either virtually disconnected or physically disconnected. So we have all different methods that basically create air gap in our product. And so that is a very big advance that we provide as part of HCI system. Also, when you have HCI, you also can do continuous testing system. Means that you can actually test your backup for any kind of dormant ransomware, malwares, and other things, or time bombs, or things that you cannot really discover that you're going to have those problems until you restore it. But when you restore it, it's too late. You already, you have been infected, or some disaster has happened, and now you're going and restoring it, and these things go off and then encrypts everything you got in your environment, and it's worse than before. So now you need to do continuous testing, and these part of appliance, since they are virtualized and those platforms and resources available to you, you can actually do continuous restore in the bubble network system that it creates. Means that bubble network, it mimics your production, pretty much how it looks like. And so it stands up those machines, tests those machines, and then, basically goes through a sequence of what it knows about ransomware, malwares, viruses. It knows about those signatures or behaviors and detects it, and then it flags you and say, hey, this backup is no good, or what you have is no good. It's going to be a problem. So you're alerted before the disaster happens to you, basically. That's what it does. So these are some of the features that it can be incorporated in this type of environment, which basically protects you against all this, misbehaviors, I would call it, right?
Yeah. I mean, so basically we've added security features and capabilities as the threats have kind of grown. And this system is better for that.
A lot better. It survives. And hopefully keep you in business, right? And, because right now we are pretty much, anybody can expect, get hit with any of these guys every minute. And it's an equal opportunity program. Means that, you could be a 5-person company, or it could be 500 or 5,000 or 50,000. It doesn't matter. It doesn't know anything about this and that. It just basically, once it gets in there, it would encrypt anything you got. So it doesn't say you're a 50,000 company, so I'm afraid of you, I'm not going to do it. No, it's going to be happy. I've seen a lot of companies get affected like this, which are huge company with a lot of resources, or a small company. It doesn't matter. Anybody who has data and anybody has any access to any kind of programs that is running, or internet, or emails, or this and that, or whatever, social engineering, you're exposed. So you're going to get hit one way or another. It's just a matter of time, right? So you might as well just be prepared and protect yourself. And part of the ways of protecting is actually knowing how to protect yourself. And these are some of the methodologies or methods that we use to basically protect the businesses.
Yeah. Okay. It makes a lot of sense. Let's get into use cases. So what are some of the common use cases for HCI, and where is this technology most suitable? I know you said everyone with data is at risk, so I imagine that the answer is kind of everywhere. But what do you think?
Yeah, well, I think, if I was going to do anything over 3 machines, 3 servers, I go HCI. Because at that time, it really doesn't make any sense, unless you have a very specific reason you are not. But in general term, anybody over 3 or 4 machines in that range, HCI is a wonderful product, right? It's basically, it gives you control over your resources, and it gives you a scalability. So if you want to add another server on it, it takes only a few minutes and you can spin up another machine, versus, going buy a server takes days, months, these days with this supply chain, maybe it takes months, before you get that server. versus in HCI, it could take a few minutes, 5 minutes, 10 minutes. So the economy works for you, the manageability works for you, the power requirement works for you. You save a lot of power, you save a lot of maintenance. So everything is worked for you. The economy of it works for you. And also, as I said, integration with the backup and disaster recovery systems it's a great plus for it. Mm-hmm.
Are there any industries that are maybe more suitable than others? What do you think about that?
Well, there are some industries which are basically mostly they're single applications, so maybe some manufacturing, stuff like that. Maybe not as much, oriented toward HCI, like they're running like one application, manufacturing application, maybe that. But, then, if you go to other people who have multiple applications running, of course, HCI is there. It could be legal. Of course, they run 10, 20, 30, 100, hundreds of machines, and their legal is there, healthcare is there, large manufacturing also is there, and then, education is there, so it's just all over the place, right? So basically anybody, as I said, over 4 machine, HCI is the great option. And, so it's not, of course, if you have data centers, that you are trying to optimize for space and, the utilization of power or, the heat and air conditioning and things like that. Of course, it's a great thing because now people are building, they used to have large data center to host all these machines. Now they're kind of reducing the footprint to the smaller one and saving on the environment as well.
It sounds like this technology is incredibly important, and anyone with a complex system should be thinking about using it. Can you walk us through what a typical hyperconverged infrastructure deployment process looks like? I imagine it can't be very easy.
Well, actually, it's pretty simple because in HCI environment, there's the GUI that it's basically controls the hypervisors, where deployment of the machines and everything else. So since it's a one pan GUI type of thing, so everything is on one, and it makes it much easier because at the same place that you are, preparing your storage, you prepare your network, you prepare your servers, all that in the single pan. And so you can see that, and you can see, all the performance management, you see all the status of different things. So deployment is very simple and easy, and much easier than, you sit down, try to do single servers and then, networks, deal with networks and switches and things like that. And, connections and cables and all that kind of thing, right? So versus this is, since the network is virtualized between the machines, you don't deal with cables, you don't deal with anything. It's all mostly internal, right? Except you want to go out, which is, it's not as complicated, or, requirements are not that tough, that you have all the virtual NIC ports and, networking and LANs and, subnets and things like that. So it's much easier to do it, and incorporating some other things like features that you might want to put, like security and all that within deployment. I would say it's much, much simpler.
If deployment is the simple part, then what's the complicated part? Is it?
Well, I don't see anything complicated. It's all good. I don't know anything bad about it. Is as long as you basically figure out, your scalability when you choose it, what kind of resources you add. So sizing, I think, is the challenge. Most of the people have sizing it, because they come from physical appliance, and now you throw them in the virtual appliance. So basically they have to figure out what kind of resources they need. So if they'd be able to initially size it up correctly, and we'll help them to do that, because we can ask a certain question. We have calculators, a lot of calculators, which actually helps you to, allocate resources of that's what CPU, memory, bandwidth, on networking, on things like that, and then the storage areas and tiers and all that kind of thing. So it's very easy to configure it. But yeah, as long as you know what you want right now, and then what kind of performance you might want to get, what kind of application you want to run. So if you be able to provide a little bit of information, then we can say, okay, this needs these kind of resources, which is basically, if you look at it, what resources it is, it's CPU, memory, and storage, and network. So these are the components of HCI. So if you be able to define these 4 components, then the next one is high availability and scalability. How much can I scale? If I need to put more machines, do I go on the same unit? Yes. If you over provision CPU and memory, of course, and disk, of course, and if so it's mostly the software defined. Means everything you have is very much software defined. As you define them, then you use them, and if you want to change it, you change the definition of it, and then it would change. So your allocation of your resources change on the fly. And that's a very strong point about this. But as long as you size it up correctly, then you can use those resources. So I would say the challenge is that understanding what your requirement is, and then projecting it to now and future, right? And then getting the right size. And if you don't, then you have an idea how to scale it. Capacity. I have more slots on the server, so I can just plug in more drives, so add more storage. Or how would I add memory if I need more memory resource because I am adding more machines? Or can I change the CPU if it's not enough? I can put a bigger CPU, or I can go to the second node or third node or fourth node and things like that, right? So you can have multiple nodes. So understand your options, basically.
Can you discuss a real life scenario where hyperconverged infrastructure has helped, I'm just going to call it HCI, where HCI has helped an organization with their data storage and data recovery needs?
Yeah, I mean, we have many situations which, if their existing production, which are, let's say, it was vulnerable and it got compromised, if their backup consists of HCI, means that you can restore the whole production into the HCI environment as in the backup environment, which is based on HCI. And has integration with that. They can restore the whole thing and just be back in the business in almost, I would say, no time. It depends, how many machines they want to restore and get back in business and be whole. And then once their production comes back, then they would just basically replicate back to their production and build the production. So these are, we have seen in legal environment, a lot of lawyers and stuff like that. We have seen those things, has performed very well. We have seen in the healthcare has done very well, so because these are, and education, of course, and then financial institutions, those we also have seen. These are, more or less under a lot of attacks and problems every day, so these are major low-hanging fruit for security hackers,
That seems like you've done a lot of work with a lot of people then. Finer points. How does HCI integrate with other technologies such as cloud and containers?
Well, they're from the same family, so they're cousins, right? So basically means that HCI, as I said, the only difference between local HCI and the cloud is pretty much the hypervisor, but it also has the same virtual machines that runs, locally or in a cloud, or container locally or cloud. It's pretty much the same thing. It's just the hypervisor different, and you don't have as much as control in the hypervisor when it's in the cloud. And then versus, the ones that if you're running locally. So locally you have full control, and cloud you have less control. That's the difference, really, pretty much. Of course, then, the cloud, uses different management interfaces. but functionality is pretty much the same. They also have pretty much a lot of data services are the same thing, like snapshot, replication, dedupe, or other things, other data services they might have. And also HCI Local has the same features that they have. So the only major difference I see, who owns the product, is that AWS owns the product or Azure owns the product and run it in data center, or you own the product, right? So, and whoever owns the product owns the hypervisor. So then then if limitations gets imposed on if somebody owns the hypervisor. So, because you also have other people on the same appliance when you go into the cloud. So you share the same HCI basically. So that's why they don't give you full control over the hypervisor.
How about integrating with existing infrastructure? How does HCI integrate with existing data center infrastructure and support like legacy systems?
Yeah, no problem, because it uses the standard protocols and on the network. So basically, communicating with other legacy environment uses TCP/IP mostly on the network, on the machines, virtual machines, Linux, Windows. So they're all the same. So the legacy system does not really know this guy is HCI next to it or it's a physical appliance. It's pretty much the same. So it has no problem. It integrates right. So you can actually go in there, and most of people do is that maybe they have like a 10 physical machine, and they go in there and then you say, oh yeah, I need to virtualize and HCI type of thing. Maybe 7 of my machines, So they reduce it to one HCI appliance, and then maybe they want to keep 3 of their machines. And mostly the reason they want to do that because they have old software and old maybe operating systems, and they don't want to touch that and virtualize it, right? Sometimes it's very specific, or basically certain workloads or something, which is still what we call legacy, right? It's older stuff they don't want to touch as much, and they are feel more comfortable with that. So maybe that's why they keep maybe some of their machines, but most of the machine gets virtualized and becomes HCI. And of course, some of the storage, when it becomes HCI, you already have integrated storage system in there. So they either retire those or just keep them as working with the legacy machines. So it works very well. So it depends what you try to take out from your production and convert to HCI and what you want to keep. And that has to do with the requirement of the system than anything else. And all usually legacy system, they might have some requirement running on the special old version of Windows, for example. And, so they prefer to stay with that, not touch it until the sort of getting out of it and just moving to HCI.
I know we talked about some of the challenges in not the deployment process, but the use of HCI. But are there other challenges, like common challenges or pitfalls maybe, that organizations might face when they're trying to adopt HCI?
Yeah, I think, one of the things is important is standards, right? So when you go with the standards, then you're safe. Some people, they go with modified version of like a hypervisor, right? A KVM modified and things like that. They usually start creating compatibility. So there are HCI systems that they use their own hypervisor to save money, or because like some of the hypervisors like KVM or Zen and stuff, they're free, they're open source free. So, and some vendors, they actually use those, which is great, but the problem is compatibility. When you want to back them up, all of a sudden you run into compatibility. When you want to integrate it with some of the packages, then you run into problems. So I would go with something which is more supported, so more mainstream, so you don't get stuck with something that you cannot do, basically. So usually we recommend VMware or Hyper-V as a hypervisor in HCI because it's more mainstream, more supported, and support is a big deal. It's a very big deal on compatibility, but also security, right? and support. So these are some of the stuff you got to watch. And so that's one thing. And then, of course, the sizing of the thing, again, I emphasize to be able to size it correctly so it meets your requirement today, but at the same time, you can upgrade it and scale it, and also make sure the high availability there as you require. So see, what kind of redundancy you require, what kind of high availability you require, so it meets your SLA basically.
Meets the requirement today and tomorrow, wherever you're going.
Exactly. So these are the challenges people have, but if you pick up the right vendor to understand all this and walk you through it, you should be good. And that's the whole idea, right? That's the whole idea of buying something that works for you and continue working for you, and cost of ownership is low, and has a pretty good life.
Let's talk about trends. In what ways is the HCI market changing in response to customer demand and this as a service style consumption that we have today? Is there HCI as a service?
Yeah, if you look at private cloud, when you call it private cloud. So private cloud, of course, could be your cloud, could be MSP cloud, managed service provider. So most of the bigger public cloud, of course, we talked about it, they use their own hypervisor or modified version of their own hypervisor, like Hyper-V modified become Azure, and then, the KVM maybe get modified becomes Amazon. Now, what happens in a sort of a private cloud either is yours or is MSPs, somebody managed service provider provides it. But they also provide the HCI. So HCI is their cloud, basically, most of the time. So basically, it means that, you can offer HCI as a service, but it's offered to you either, as I said, you buy it and you put in a data center and then give yourself a service, or you just get it from MSPs and specify, okay, I want this HCI/cloud, have this much resources, this kind of virtual machines and things like that, or they might just provide that to you as well, not as an appliance, but more or less, again, with another software, which basically it's a sort of cousins of HCI, which is, as I said, modified hypervisor, and then, call it cloud and give it to you but at the end of the day, it's the same technology, same idea, is used as a service. So they partition it between different users, and then different user can sit on that appliance. That's why they might call it cloud. Versus, if they say HCI as a service, means more or less they want to give you the appliance as a whole, so you kind of own the whole appliance in their data center, and you get the whole resources. So that might be something you prefer because you have more security, you don't have noisy neighbors and stuff like that, and other things, right? So yeah, you have to inquire with MSPs or your vendors if they would be able to give you either one.
How about edge computing? Is HCI always a good fit at the edge?
It could be, right? It could be. It depends how it's configured and what kind of resources you want to have at the edge. Yeah, it could be, but as I said, HCI will shine if you have more workload to run, so more servers. So usually edge is very specific, so may not need as many servers running on the edge. Maybe not as much versus other use cases that you might have, which utilization is required, and hardware required. It would be key, and so it might use it there.
What's your opinion about the prospects of software-only options?
It's great. It's fantastic. We sell that. So if you bring your hardware, then we sell you software as optional, right? So no problem. It's called software-defined storage, or SDN, I think, right? Virtual machines. So, and yeah, we do sell it as software only. So if people have a hardware and they want to utilize their hardware efficiently, they just basically reprogram it with or SCVM, and then they would have that version. Actually, if the software runs bare metal, then they call it bare metals. We have that. It's called the Stone Fusion. So that is Stone Fusion. When it's a virtual machine, we call it SCVM. You can buy it as SCVM. When you buy it in the cloud, we call it cloud. So we have 3 versions, but they are the same version, but it runs in different places. So you can buy our Stone Fusion, run it as a bare metal. You can run it as virtualized, which is HCI, or you can run it in the cloud. All 3 versions available, and it's the same product.
Well, let's move to the closing question. This is the big moment we've all been waiting for. What advice do you have for organizations considering implementing HCI for their data storage and recovery needs?
Well, one of the things is that, define what your requirement is. So based on that requirement, size up the equipment correctly. And then, I think the sizing, as I said, is to emphasize the sizing. And then, of course, what data services you want, and what kind of protection you want. What is your business requirement for all this? So if I want to go do this, is that I would go look at my requirement today and maybe a year, 2 years, 3 years, 5 years plan, what might look like, and then, based on that, determine what the size of the node is, when one single appliance node is, and how would I scale it to have more and more to take me to next 5 years. And then, so also I put integrated protection as part of it. Always do that, because these days, if you don't have it, you're out of business already. You just don't know it. So basically, it's important to have all that integrations and be able to scale and stay as far as high availability and then, security.
Well, that was really interesting. I feel like I do feel like I learned a lot here. Before we get out of here, Mo, what's the best way for our listeners to reach you? And then if you have any, asks of the listener, now's a good time to include those.
Yeah, so the best way is actually go to our website, Stonefly, which is www.stonefly.com. And then if you have any sales questions, sales@stonefly.com. So that usually, it's a good way of getting us. If you have any technical question, you can go to support@stonefly.com. So they can answer all the questions. But sales is usually a technical sales, so they're familiar with all the questions that might come in as far as, if somebody wants to size any kind of products and see how to go about looking at anything that works in their environment. So sales is sales@stonefly.com is. And also, if you are going to call us, 510-415-1616, and all the information, contact information is on the website. So, and we are globally serving the customers. So anywhere in Northern California, United States, Canada, then Australia, and then we have offices in Middle East, Africa, Europe, so South America. So everywhere we are there. So we will be more than happy to serve anybody who wants to ask questions, have any needs for our product.
Sounds good. All right, we will end the show there. Actually, one more question. Surprise question.
Okay. All right.
Everyone's remote nowadays. You worked at Atari, Sun Microsystems, and now the startups. Are you located in the Bay Area? Where are you?
Yes, I am located actually in the heart of Bay Area. So I'm between San Francisco and San Jose. Right. So I'm actually here. So physically here, I'm actually in my office, So yes, I do work remote, but I work in my office pretty much because also my production is in Bay Area, so it's next to me. So I like to go walk in production all the time, make sure, So.
Yeah.
Yeah.
Make sure it's working. Walk around. I'm imagining like that scene. I don't know if you've seen it from Silicon Valley, where it's like they just zoom out. They're in a data center and they just zoom out, and it's just like bigger and bigger and bigger.
Yeah, that's exactly what happened.
Sounds like a nice stroll. All right, Mo. Well, if you liked our show, please subscribe wherever you listen to podcasts. Thank you, and leave us a rating. Mo, thanks for joining the show. It was awesome to have you on. We appreciate you taking the time out of your day to do this.
You got it. Thank you so much for having me, and you guys have a wonderful day.